Hello, today we want to talk about energy. Energy is involved in all chemical reactions and chemical changes. And energy is what really drives everything. The truth is we're never going to have any kind of chemistry without energy moving in the system. So we need to talk about energy. Where is it at? What's it causing us to do? So I want to talk about energy. Energy in its simplest idea, it says in our book, is the ability to do work. And so if you don't have energy, you cannot do work. So energy is like a battery. It's got energy in this battery, and so if I put it into a machine, a toy or a clock or whatever, that machine can work. But if the battery is empty, it has no energy, it won't allow the clock or the toy or whatever to work, or your flashlight. Okay? So energy is a driving force. Okay, if you don't have any energy, you're not going to get up in the morning. So energy is our driving force we want to talk about today. So energy is we've defined as the ability to work. There are two kinds of energy. And those two kinds of energy that we think about are what we see in everyday life. We have potential energy and kinetic energy. And they're really simple to define. Potential energy is like gasoline in your car. It's in the tank. It has the potential to get the car to move over. So potential is like stored energy. It's stored in there. If I stretch the rubber band, it has the potential to do something. So potential energy is stored energy, something that could be used but is not being used. Kinetic energy is energy that's in use, or we call it energy of motion. So once you push on your gas pedal, and your potential energy, or the gas in your car, goes into the engine, it begins to turn the engine, which turns the wheels, which then pushes your car down the road, and now your car has kinetic energy because it's in motion. So we've turned one energy into another energy, okay? So potential energy and kinetic energy are types of energy, okay? And we want to talk about those kind of things as they work, because every chemical, the food you eat, has stored energy in it. And every time you eat that food, chemical processes occur in your mouth and in your stomach and in your intestines, and it turns those chemicals into energy that you can use. So when you drink pops and you drink sugars and that kind of stuff, the chemicals in the sugar begin to turn into kinetic energy. Now your muscles work, your brain's working, your eyes looking, all these processes are going, your bones are growing, and your body's healing itself. So that's where the chemical energy comes from. Without those energies in that food, you would not be able to accomplish what you're accomplishing. Like even thinking about chemistry, which is very important. So we're going to go back here and talk about them a little bit more. And so I want to talk about two terms called endothermic and exothermic. Exothermic and endothermic are which way the energy is moving in a system. Exothermic is if a system, and it can be boiling water, it can be a chemical reaction, the food breaking down in your stomach, is releasing energy. And whenever energy is released, then we have a process or a system that is exothermic. Endothermic is a system that is absorbing energy. Okay? And so it's not too difficult. So this is the directional flow to a system. Okay? So I want to talk about those ideas, and I want to put those in more clear terms. So let's talk about solid, liquids, and gases. We all know what ice looks like. We all know what water looks like. We all know what steam looks like, because we've all seen that and done that in our kitchens, and we've drank and pop and that kind of stuff. But I want to talk about which way is the energy going. If I want to turn ice into water, I have to do either an exothermic or an endothermic change. Well, what is it? Well, think about it. If you want ice to melt, you pull the ice out of the freezer, and because the heat in the room begins to enter the ice, it begins to loosen its particles up and pull apart and turn into water. So from going from solid to liquid, I need energy to get into the ice. So it needs to absorb energy. So this process is endothermic. Okay? So that's what we would say. So solid to liquid is endothermic. Well, what if I wanted to turn that water, which now sat in the cup from the ice and wants to turn back into ice, then I would put it in the freezer. Well, what would happen? Well, the heat in the water would then try to go out and warm up the freezer, but it couldn't do it. So to go backwards, we would have to have the energy come out of the water, slow the particles down, and then refreeze. So this would be a exothermic process, okay? And so what we're doing, what we're talking about, is an idea called the kinetic theory. And the kinetic theory is when we're talking about motion of particles, and we'll talk about that more later on. So let's go back to our idea of exo and endothermic. Let's think about water turning it into steam. You've got a pan of water and you want to turn it into steam. What are you going to do? You're going to turn on the stove. When you turn on the stove, you're adding heat into the pan of water. The particles begin to warm up and move faster and begin to bubble and then actually turn into steam and then leave the pot. But to get it to turn into steam, we had to add energy in, so the water had to absorb energy, so that makes it again endothermic. So endothermic, absorbing energy, okay? And then if that steam moves around the room and touches maybe the window in your room or the refrigerator, something cold with metal, you notice there's droplets of water on it called condensation. Well, that meant the steam gave up its energy to whatever it touched, maybe the window in the room, and then droplets of water formed, so energy had to come out, so that was exothermic. So every change in chemistry is either exo or endothermic. And we're trying to define that for you today. So we want you to understand this process. Anytime a system takes in energy, that is an endothermic process. Any system that gives off energy to release it to make the change is called exothermic. Okay? So there's some basic phase changes on exo and endo. But I want to close here really quick with an exo and endothermic chemical change. We did a lab where we took magnesium metal, we burned it in oxygen. Now we added a little heat, but once we got it burning, it gave off a whole bunch of heat, kind of like when you're burning wood. And we formed magnesium oxide. And that magnesium oxide, which is in fireworks, gave off a really bright light, gave off a lot of light and a lot of heat. So that means energy exited the system. And anytime we find energy on the product side, that E is really meaning exothermic. It means it's a product. It's something that comes off of the reaction. Okay? So anytime a reaction occurs and gives off a whole bunch of energy, we call those exothermic chemical reactions. A lot of those occur in your body. That's why we stay warm and we eat food. The food breaking down makes it give off food the heat that we need to run our whole system. And so one system helps another. The next one is we want to do an endothermic process. So to do that one, I want to show you one. If we take baking soda, NaHCO3, and we put vinegar or any other acid, I'm just going to use HCl as an acid, okay? When they chemically react, it bubbles and fizzes, and you would think it's warm, but actually it's quite cold. And the reason why it's cold is because when it makes the water, the salt, and the carbon dioxide, the reason why it's cold is it's drawing out energy from the environment because it can't happen without energy. And the reason why it feels cold is because it's stealing energy from our hand as we touch it. And so anytime we find E or energy on the reactant side, it means endothermic. Okay? So endothermic are reactions that need energy. Energy has got to be put into the system. Think about your boiling water again. If you're boiling water on the stove, I know it feels hot, you think it's giving off energy, but think about if you turn the stove off, it would stop boiling. That boiling water needs energy. It's constantly absorbing it to turn into steam. So that's endothermic. Okay? Reactions that feel cold are endothermic. They're drawing energy out of your body and absorbing it into the system. Okay? So anything that feels warm, a lot of times is giving you energy. So when we burn magnesium, we burn wood, as it burns, it gives off tons of heat and heats other things. So energy is on the product side, and that is considered exothermic. So in our recap, we talked about energy is the ability to do work. Work to get done sometimes is given off in one system, and then absorb it in another system. And anytime you need an endothermic system to work, you need an exothermic system next to it to give it the energy. So guess what? You can't boil water without an exothermic process of gas burning underneath. So a gas stove, it burns, gives off heat. You use heat to then boil your water. So exos and endos are always found together, even in nature. Okay? That's our first idea of energy.